So C arctan of tangent pi over 4, and because tangent graphs are 1 to 1 from negative pi over 2 to pi over 2, that's the restricted domain. So inside this restricted domain, you have pi over 4 here. Therefore, in that case, they're just inverses of each other. So if you're inside the restricted domain, you can just simply cancel. There's no problem with it. Now D, sine of arc secant of radical 2. Okay. Now that's tougher. Now you first have to figure out what arc secant of square root of 2 is. Now let's just say it's equal to x. Now what does that mean in terms of secant? What's the relationship between arcsecant and secant? They're inverses of each other, right? So what does inverse functions do? No, inverse function is not the same as reciprocal. They're totally different things, okay? The reciprocal of secant is sine, but the inverse function of secant is arcsecant. They're totally different functions. Okay? What does inverse functions do? Okay, so you can think of them as canceling if you compose them. That's one way to say it. What's another way to say what's an inverse function? Yeah?
Secant of x equals radical.
Yeah. Switch x and y, right? Or switch the input and output, right? So you plug in input as square root of 2 and you get the output as x. Inverse functions switch input and output. So you switch these two around, that's the inverse, okay? Reciprocal does this. It switches up and down, right? That's different than inverse functions, which switches input and output. Okay, so this is what you have. Now, secant is the reciprocal of sine. No, not sine, cosine, sorry. I made a wrong comment. Secant is the reciprocal of cosine. Therefore, I can flip both sides and get cosine of x as 1 over square root of 2. And since this is not rationalized, let's multiply radical 2 top and bottom. So you get radical 2 on the top, radical 2 squared is just 2. Oh, I know that value. That's the one that has the nickname of medium size. Okay? So the medium size, when does the cosine become the medium size? Right? 45, pi over 4, right? So after all this work, we figured out that x is equal to pi over 4. Therefore, we have to know what sine of pi over 4 is, which is radical 2 over 4. Now let's do a similar one. E, cosine of arc cosecant of 5. Same deal. You first figure out what arc cosecant of 5 is. Oh. No, it's not the same deal. See, if you put this as x, now it's slightly different because if cosecant of x equal to 5, which means 1 over sine of x is equal to 5, which means sine of x is equal to 5. But unfortunately, what? No. I have to take the reciprocal part. Okay. So we have sine of x equal to 1 over 5. But unfortunately, 1 over 5 is not of any of the form radical over 2. Right? Those three special values, small, medium, large. This doesn't fit into any of them. So therefore, what we have to do is, instead of coming up with the actual value, we have to represent this as a graph, okay, using SOHCAHTOA. Right? So using SOHCAHTOA, sine is what over what? So if I say this angle is x, where should I put the 5? Opposite of 5, x. No. Where should I put 1? Right? 5 goes to the hypotenuse, right? 5 and 1. Okay. Now, can you also figure out what this is? 5 squared is 25, 1 squared is 1, 25 minus 1 squared is So if I say a squared plus 1 squared is equal to 5 squared. Solving for a, this is 24 square root, which is 2 radical 6. Okay? So this is 2 radical 6. Now only after this, we can ask, since our cosecant of 5 is what we call as x, we can go and say, this is cosine of x, and according to this graph, what is cosine of x?
2 radical 6 over 5.
Because of SOHCAHTOA, chi is cosine is adjacent over hypotenuse. Okay, so that's how you do it.